In this presentation, I will be demonstrating the integration of Smallworld and AutoCAD map products using the SBS SW Provider. To retrieve data from Smallworld, I will be using the Smallworld Toolbar. The Smallworld Toolbar provides a series of functions predefined within the Map 3D environment which allow me to retrieve and manipulate data. Grid Manager allows me to retrieve data in a read-only fashion based on grids or geographical areas defined within the Smallworld database. Activity Manager allows me to retrieve data from Smallworld by defining a brand new design within the Design Manager application. Data is then retrieved from within the bounds of the new design. The Design Manager application allows me to retrieve data for an existing design within Smallworld. And finally, the Open World function allows me to retrieve the internal world contents for a feature which is selected within the Map 3D environment. In addition, the Smallworld toolbar includes the Checkout, Check-in functions. In this demonstration, I'll be using the Design Manager application to retrieve data from an existing design. When I click the Design Manager function button, the Design Manager dialog is displayed. This allows me to search for designs within the Smallworld environment. I may search on a number of different fields to define the spatial and physical query. In this instance, I'll be using the ID field and specifying FDO. When I press search, any designs where the project name includes FDO are listed below. I then select the one that's returned. I can elect to make it writable as a retrieval, and then I can indicate what data I wish to retrieve. To do that, I'll be using themes. Themes are predefined groupings of Smallworld features which are saved within an XML configuration file similar to an Autodesk layer file. The theme includes information like the features, the symbology, the adaptive scaling and visibility controls, and it also includes information which allows it to be defined within the Display Manager. In this demonstration, I'll be working with gas facilities. When I connect, data from the Smallworld database for the predefined themes is loaded automatically into a new design file. As I zoom in, adaptive scaling will turn on features which are only visible at higher scales. In this instance, fittings and service points become visible as I zoom in. Looking at the Display Manager, I can see a list of the various features organized in a hierarchical tree. This tree mimics the object control visibility settings defined within the Smallworld database. Selecting a feature, I can elect to display the symbology associated with that feature. Here I have a fitting object. The representations of the fittings are almost identical to that in Smallworld. The theme that was used to retrieve the data has encoded the symbology from the Smallworld database, and it is that is then used to display the features. The symbol has actually been downloaded from the Smallworld style database using a predefined process. Available symbology that's used within this drawing file is currently displayed. In addition, I can open the dumped file containing all the symbols from the Smallworld style database. My theme can then use any of these symbols to allow it to represent the data. Other information, including the height, the size context, the units, the rotation, are all encoded as well. Different symbologies are available through thematic rules, which are driven by either style mapping or geometry mapping from the Smallworld database. In this instance, symbology changes based on the type of the fitting. Also, adaptive scaling allows different scale ranges to be made visible as I zoom in and out. In this instance, fittings are visible from 0 to 4000 and then become invisible beyond that scale range. Different scale bands allow me to define different symbologies associated with those. Again, these are all predefined and saved in the theme. In my example today, I'll be creating new features and sending them back to the Smallworld database. To start, I will create a new main. To populate the attributes for this case, I will copy and paste attributes. Having pasted the values, I will then make some changes to specific attributes. Next, I'll define a new service line. Rather than copying and pasting, I'll enter the values directly. Enumerated lists show existing options which have been downloaded from the Smallworld database. With these domains, I can only select from predefined values. Now I will delete an existing service. And finally, as part of my changes made in this job, I will update the service point. The sum total of my changes in this design now include a new main, a new service, an update to an existing gas service point, and the deletion of an existing service. Having made these changes, I can save them and carry on with more design work. For the demonstration, though, I will check these changes back into Smallworld. When I click the Check-in button, it reports back that all features have been checked in. The changes that I've sent back to Smallworld have not been made directly against the main service and service point tables. The changes are held in a job manager database. This short transaction database allows me to record the transactions as XML objects, which can then be played into the database by an operator, allowing them to visually inspect the changes that are being made and, if necessary, make changes on the fly if values are incorrect. The next part of this demonstration transfers over to a Smallworld session. Within my Smallworld Design Manager session, I have a new tab that shows jobs that are available to users to work on. If I select to refresh, I can see a new job has now been added into this environment. If I select the job, I can see details associated with the job. I can see the name of the job, who created the job, and what machine they were working on, and other additional information. The activity ID allows me to see the design scheme that this job is associated with. Currently I'm in no design, but by selecting the Select Activity option, I can then say open the design associated with the selected job. Having selected the job, I can now go ahead and inspect the contents of the job packet. I see a number of elements within this job. An update for a gas service point, an insert for a gas service, a delete for a gas service, and an insert for a main. At any time, I can opt to view the changes that are there. If I redraw the screen, I can see the data available. As I zoom in, I can see the features associated with the job highlighted in red. If I unfold the job elements further, I can see individual bits of information related to each. Specifically, the update on the gas service involves changing the type field from unset to residential. The service includes inserting a new record with the following values. And finally, the main involves installing a new main with the following values. To load these XML job transactions into real Smallworld objects, I need to select and run the job. I could select the job at the top and press the run button, and it would run all elements in order into the Smallworld database. However, in this case, I will play each element in individually. The update to the gas service, if I press run, that has now changed the gas service. I insert another service, I see the line insert. I delete, and finally, if I select to insert the main, the run option is not available to me. The reason for this is the install date is not of the correct format. It includes a date time. So in this case, I have to manually run the process in. I can select the main directly and then open up the editor, substituting the values from the job packet in. I then select the install date and manually select the date I wish to use. Finally, I insert the record and the main is created in the database. Going back to the job, I now know everything is complete with it, so I'll mark it as complete and the job is then finished. I can now select existing records and review the attributes associated with them. I can see the new proposed service, the update to the service point, and the new gas main. In addition, as the objects are loaded, the topology is also created. So I can verify as well that my connectivity has happened properly.